Hi friends, this is Sarvajan here. Welcome to my networking channel. Hope all are doing good and safe. And today let us discuss about OSPF broadcast over a frame relay network. So the example is an Ethernet. So in the broadcast network, the OSPF will elect DR and BDR neighbor relationship, and the neighbors are automatically determined. Since it is a broadcast, the neighbors are automatically determined. So here I connected three routers to a frame relay switch. So each and every frame switch I assigned a DLCA, right? So each and every virtual circuit, this is a virtual circuit and this is another virtual circuit from so virtual each and every PVC I assigned a DLCA. So what we called as a data link connection identifier, which is locally significant. That means for R1 to R2 the DLC value will be 102, and from R2 to R1 it will be 201. Similar way from R1 to R3 that is 103, that is a PVC, and especially from R3 to R1 the PVC will be 301, that is a DLCA, and this connection identifier is assigned by LMA, that is a local management interface. So for mapping DLCA to IP address we'll be using a inverse ARP, so that is our default enabled on all these interfaces. So in case of switch, it will forward the information based on MAC address. In the frame relay technology, we'll use the DLCA. So the DLC is nothing but a locally significant, which is assigned by with the virtual circuit. So each and every virtual circuit will be assigning the DLCA. And for mapping DLCA to the IP address, we'll be using the inverse ERP. So by default, inverse ERP is enabled, right? So now let us go to the architecture. So this is a frame relay switch. I already configured the two DLC 102, 201 other end, and this is 103 and 301. This is the way I can configure the frame relay switch. So these are the individual virtual circuit, right? So now let us go to the configuration. So let us go to R1 and let us configure the individual neighbor relationship. Before that, let us configure the interface. I have to configure the frame relay interface, right? I have to enable the frame relay. So go to the interface mode. Interface serial 202 by 0, and you have to specify encapsulation frame relay. Since it's a frame relay network, I'm going to configure as an encapsulation frame relay. And then I have to configure this as a broadcast network, right? So this is a broadcast network. An example is an Ethernet. So I have to specify IP OSPF, and the network I have to specify is a broadcast. So you have to always specify this keyword broadcast. Only the neighbor relations will be automatically determined. So this is a hub, and these two are the branch office routers. So now let us go ahead and configure R2. Go to the configuration mode and interface fast Ethernet. Sorry, it is not fast Ethernet, it is serial 2 by 1, right? So it is serial 2 by 1, and let us configure the encapsulation frame relay, and then we have to configure the network. IP OSPF network is broadcast, right? So we already configured this as broadcast, and I already specified the individual interfaces. I already configured the directly connected interfaces. So only thing I need to configure the frame relay and the broadcast network, right? So go to R3 and go to the configuration mode, and what is the interface? Serial 2 by 2. So interface is serial 2 by 2, and the encapsulation frame relay and the IP OSPF network is broadcast. So you have to specify broadcast on all the R1, R2 and R3. So let us see the directly connected interfaces. Page show IP interface brief. So here I configured the IP 1.3, and here this one I configured as 1.2. Show IP interface brief. So this I configured as a 1.2. Similar way, show IP interface brief. So this I configured as a 1.1, right? So I configure the individual interfaces. So that then one more thing is pending. I have to enable the routing protocol OSPF over this frame relay network. So go to the configuration mode, router OSPF 100. So network is 192.168.1.0 followed by 0.0.0.255 area 0, right? Similar way, go to R2 and configure the routing protocol. So router OSPF 100, and the network is 192.168.1.0 followed by 0.0.255 area 0. And go to the configuration mode, router OSPF 100, network is 192.168.1.0 followed by the wildcard mask and followed by the area. So everything I configured, and one more thing is pending. So in case of OSPF broadcast network, the DR VDR election, what we have to do, we have to always configure the branch office router. This is a hub and this is a branch office router. I have to always configure this as a priority 0. So that means I already told IP OSPF priority 0. So this R2 and R3 will be elected as a DR other. So what happened to maintain a full mesh neighbor relationship with R1? So for both the branch office router to establish a neighbor relationship with the main office router, we have to enable this as a DR other in case of broadcast network. So that's the thing already configured. Go to show run. So this is the thing I configured, right? Show run serial 2 by 1. I configured this as a IP OSPF priority 0. That means it will be selected as a DR other. Similar way I configured for R3 also. So now let us check the individual neighbor relationship. Show IP OSPF neighbor. So it has already established a neighbor relationship. That is the reason you are seeing the branch office router as a DR other. So in this OSPF broadcast network, I have to configure the remote router, that is a branch office router, as a priority 0. Then it will be elected as a DR other. So this will be so that both R2 and R3 will establish a neighbor relationship with the R1, right? This is a DR. Similarly, go to R2 and show IP OSPF neighbor. So it has also established a neighbor relationship with DR. This is the main office router DR. Similar way, go to R3, show IP OSPF neighbor. So it has also established a neighbor relationships. This is the example of OSPF, right, on a broadcast network. OSPF broadcast on a frame relay network, right? So let us check the frame relay PVC status. Show frame relay PVC. See, you are able to see, right? The PVC configured is DLCI 102, which is active, PVC status is active, and the interface is 2 by 0. Similarly, 103 PVC status is active and the interface is 2 by 0, right? There are two virtual circuit I have defined. One virtual circuit from R1 to R2, that is DLCI 102, and R1 to R3 is 103, and both the PVCs are active and both having the same interface, right? Similar way, you can check the map status also. So frame relay map will show the, so you're able to see, right? You are able to see the map DLCA. This is a mapping DLCA to IP. So this mapping is done by inverse ERP. So already inverse ERP by default is enabled. So this will map the DLCA to IP address for the communication over the frame relay network, right? So similarly, go to R3 and check the show frame relay PVC. So it will be active. So this PVC also active, especially check the map details. So it will show the map detail, IP and the DLCA. So this is how the frame relay network work. This is an example of the frame relay, like OSPF broadcast network over a frame relay network, right? So let us check the show frame relay LMI. So this will show the LMI status. So LMI status is used to enquire the status of the PVC, whether the PVC is active, R1, R2, R3, whether the virtual circuit is active. So for that inquiry, we will use the LMI. LMI is a local management interface. And another thing it does is it will assign the DLCA to the virtual circuit. So each and every virtual circuit, it will assign the DLCA. So that function is handled by LMI. I hope you understood. Thanks for watching. Please subscribe me for more videos. Thank you. Have a wonderful day.